an infinite geometric progression has the sum equal to 10, and we are required to find out the possible integral values of each of the first terms of all such possible geometric progressions. So whenever you hear about an infinite geometric progression, what exactly does it mean? It means that a geometric progression is of the form ar square dot and ar to the power infinity. Basically there are infinite such terms. Now an infinite geometric progression is defined only if the value of r, that is the modulus of r, is less than 1. So each of the terms, the absolute value of the terms is actually decreasing, and for those kind of geometric progressions we have the sum possible. So for example, for any geometric progression where the first term is a and the common ratio is r and the number of terms is equal to n, the sum of the geometric progression is a into 1 minus r to the power n by 1 minus r. Now, for an infinite geometric progression, modulus of r is less than 1. So, r to the power n, as n becomes very large, if n becomes infinity, r to the power n becomes very close to 0. So, the sum of a infinite geometric progression is equal to a by 1 minus r. Notice that in this case, r to the power n or r to the power infinity is assumed to be 0. So the value of this geometric progression is, sum of the geometric progression is a by 1 minus r. Over here we are told that there is a infinite geometric progression such that its sum is equal to 10, and we are required to find out all the possible values of the r, of all the possible values of the first term, which is a. Now, as we discussed earlier, for an infinite geometric progression, the modulus of r is less than 1 and it is greater than 0. So, r lies between 1 and minus 1, and r will not equal 0 because common ratio of 0 doesn't make any sense. So, over here we can easily calculate the value of a. So, a is equal to 10 into 1 minus r, or a by 10 is equal to 1 minus r, or r is equal to 1 minus a by 10. Here we know the boundaries of r. We know that r lies between minus 1 and 1, so we can easily calculate the boundaries for a. So 1 minus a by 10 will lie between minus 1 and plus 1. Or if we subtract 1 from all the inequalities, minus 2 is less than minus a by 10 is less than 0. If we multiply all the inequalities with minus 1, we'll have to change the inequalities also. So this will become 2a by 10 and 0. But because we are multiplying with a negative number, the side of the inequality changes. So this becomes 2 is greater than a by 10 is greater than 0. Or a 20 is greater than a is greater than 0. But we also know that the common ratio r will not equal 0. So this implies that 1 minus a by 10 is not equal to 0, or a is not equal to 10. So here we know all the possible values of a. A can be 1, 2, till 19, but a cannot equal 10. So the sum of all the possible values of a will be the sum of the first 19 natural numbers minus 10. So the sum of the first 19 natural numbers is 19 into 19 plus 1, that is 20 by 2. Remember that the sum of the first n natural numbers, that is sum of 1 plus 2 plus till n, is equal to n into n plus 1 by 2. Over here, when you are substituting the value of 19 for n, we will get 19 into 20 by 2, this is equal to 190. From this sum, we will have to subtract 10 because a cannot equal 10. So this will be 180. Therefore, the sum of all the possible values of the first terms of geometric progressions, of infinite geometric progressions, whose sum is equal to 10, is 180.